Hey guys, welcome to my little mini-series on how to use my RLBot utilities, which is VirxERLU, and I'm going to be assuming that you already know Python, that you already know how to set up your bot with the config and all that kind of stuff, and I'm just going to be showing you how to use these utils specifically. So, in order to get these utils, you're just going to want to come to this GitHub page, VirxCC, VirxERLU, and then just download the zip file. And now you're just going to want to extract this zip file and to open it inside of your editor. Alright, so now that I've done that, as you can see, I have all these things right here. And in requirements.txt it says tkinter. Now, you cannot get tkinter from pip. It is not a pip package. It is built in to Python. And if you're getting an error while running the bot about tkinter, then you're going to want to update to the newest version of the RLBot GUI. This is because tkinter comes with Python, and if you have an incomplete Python install, then tkinter won't be in there. So naturally, we have our logo.png. You can replace this with anything you want. It will replace the icon in the GUI, both the debugging GUI and the RLBot GUI. There's also this license right here, which quite literally is the unlicense, stating that all of this code is in the public domain for you to use, modify, and distribute however you want. And I have this gitignore file that comes with it. This will automatically ignore all of the extra Python files. So, if you want to get started with programming the bot, come over here to main.py, and here we go. So we have our initialization function right here. So it will be run once the agent has built all of its data, including all the boost pads, the player list, the ball location, all the player locations, stuff like that. Also, hot reload is not enabled due to the fact that the GUI just isn't compatible. I tried as hard as I could to get the GUI to work with hot reloading. It just doesn't work. So instead, you're going to want to go to extra and then continue in spawn. And this is basically the same as hot reloading, except it isn't automatic and it's manual. Next, there's this tournament option right here. What the tournament option is basically you should enable it for tournaments. Or if your bot gets put into our community botpack, which would be amazing by the way, then you should enable tournament mode. What this does is it strips away all of the debugging things just to get it out of the user's way. So heading back to main.py, we also have our demolished code. So whenever your bot gets demolished, it will run this function every single tick that it is demolished. And then the run function is the opposite. If you are not demolished and the game is currently active, will this function run? And this is just so your bot isn't running its very expensive main function while a replay is going on. It doesn't make any sense, and you can change this again in the agent if you want to. Handle match comms. Now, I already have a quick thing. In fact, if you import utils as well as everything else. In the utils function, there is this, the send comm function. And what this does is it takes your team number, because your communication gets broadcast to anybody and everybody, including the other team. So just pass in this little team variable into the object, and then send that object. And then when we get it, check if the message is from our team, then self.print. Now yes, you could just do print, however, self.print is a little more versatile, as self.print will automatically disable itself during tournament mode. So basically it's disables all of your debugging messages with self.print. And if you don't want a message to be disabled during tournament mode, then you can just do the normal print function. However, if something is debugging information, then definitely use self.print, which is defined right here. As you can see, it prints the name of the bot, and it will quite literally take the in-game name and just slap it in there, and then it will have the message. And then this is similar for quick chats. So if the message is from our own team, then print the quick chat. And then just to quickly show you how to actually send a match comm, just do utils.sendComm for send communication, and then pass in self, and then as a second parameter, pass in your object. This object can be quite literally anything. Let's say I have attacking, and then I have true. And then in here I do if message attacking, then do something, and then print the message. In my version of GoslingUtils, we don't have kickoff flag. Instead, we have the kickoff done variable. So what this is if kickoff done is false, that means that, well, we need to do our kickoff. And if it's true, that means we have completed our kickoff and we can now move on to our main strategy code. These utils comes with the generic kickoff routine. So all we have to do, if not self.kickoff done, then if self.is clear, so if our stack is clear, and if we are not doing anything at all, then push the routine generic kickoff to the stack. And then once that routine generic kickoff is done, the kickoff done variable will now be true. So then we can do our else statement, and here is where we will run our code while we aren't doing our kickoff. And all is clear is it just returns if the stack is empty, and self.clear clears the stack. So be very careful. If you do if not self.clear, that will always return true, and it will also clear the stack. So be careful. In fact, let's go to the routines right now. As you can see, we have this nice big long at the ball agent routine, which is a very smart at the ball agent. And with any function that requires driving, I have improved the pathfinding a little bit. As in the default GoslingUtils, the bot can get stuck in a state where it is driving in circles around the target and it isn't holding down handbrake in order to swerve and face it. So whenever it starts to do that, it immediately presses handbrake so it can swerve in and actually get to the target, and it won't just drive around in endless circles. So as you can see, there are in fact a couple more routines in here. For example, there is the shadow routine. This will automatically position the bot in order to push whatever attacker to the outside where they don't have as good of a shot on the net. It will also place your bot when it's on offense in a good place to push inwards and get the ball and get a good shot on net. And then we also have this retreat function. So what this will do is it will either put your bot directly in front of the net, or what it will do is it will place your bot on one of the goalposts. And this is entirely dependent on whether you're playing 1s, 2s, or 3s. And then we also have the standard go-to boost function, again with that pathfinding improvement. And then same with jump shot. And then you got the generic kickoff. And here we have ball recover, which is the exact same thing as recovery, except it faces the ball. I use that in the aerial function. And the aerial function is a Python implementation of the RLUtils aerial method. And this uses ball recovery. However, we also have this break function right here, and all this does is it just slows your bot down. And then of course we also have these couple of constants up here. However, we also have mutator support. So what I mean by that is, in a couple of these functions, mainly the jump shot function and the aerial function, we need to know the gravity that we're dealing with, and we also need to know how much acceleration using our boost gives us. And VirxERLU automatically handles this for you. As you can see right here at the start of the game, it gets all the mutators, and then it sets up a quick little switch statement for the options, and then it sets self.gravity and self.boostXL to the corresponding value. And we also, of course, have a couple more constants that, as of right now, cannot be changed by any mutators. And now, for the big change. In GoslingUtils, you have one singular find hits routine. This routine is extremely expensive, extremely inefficient, and it returns any and every shot that it can find. This is not a very good approach whatsoever, as, like I said, it is an extremely expensive function, and there are many improvements that can be made to it, especially when you're just going to take the fastest shot that it can find anyways. So what I've done is I've split that one routine into 4. So our first one is the find jump shot tool. And all you really need to know about this is, in here, all you have to do is just do tools.find jump shot, pass in self, and then pass in a target. And this is going to be a tuple of the leftmost shot. So let's say self.fogoal.leftpost, and then the rightmost shot, which let's say is self.fogoal.rightpost. And now you can add an optional cap, and all the cap is it caps the max number of seconds that the shot can take. So currently it's 6 seconds, which is also the length of the ball prediction struct, 6 seconds. However, you can also make it like 5 or 4 or whatever. And what happens is there's another method in here that is used by all of these methods, and it is the isFastShot. And all this does is it takes all of this information right here and it takes the distance from the car to the ball intercept, and then it basically grants the shot a half second for every 500 units that it has to travel. And then of course it caps that at the cap. So in this case I'm just going to use the default cap, and I'm going to say jump shot. And this will return the fastest jump shot that it can find. But of course, you saw there's still 3 others. So, especially on defense, you are probably going to not want to have to deal with any of the extra seconds that lining up a shot might take. You just want to hit the ball as hard as possible, as quick as possible, in order to get it away from your net. So in this case, you can use find any jump shot. If jump shot is not none, then push the jump shot to the stack. And that is how you find a jump shot or any jump shot. It's a similar process for aerials as well. So there is a find any aerial tool, and of course there's also the find aerial routine where you pass in your target and it will return the fastest aerial that it can find. But then of course there is the debugging GUI and the built-in debugging support with VirxERLU. And what it is if you are not in tournament mode, then it will launch a GUI with tkinter, and it will attach the agent to the GUI. You can change this like bot by bot maker, and then your GitHub repo right here, and you can change the geometry of the window. But you have certain debugging tools such as disable driving. Just turn on the debugging in general. This is not the same as tournament mode, by the way. This will only turn on the in-game debugging, and it cannot control the prints to the console. You have to use the tournament mode for that. And of course there's also debug 2D. Debug 2D only allows one bot at a time to debug because it debugs to the same location. And then also there's the show location 2D, which shows the current bot's location. And of course it requires the debug 2D to be on. There's also debug 3D, which takes your debugging information and attaches it to the 3D location of your bot. And this is very helpful as you can be debugging multiple bots at the same time with debug 3D. And then debugging with stack requires debug 3D to be on, and well, it debugs the stack. Debug lines. This is another form of 3D debugging. However, it does not require debug 3D. What this does is it will show you, for example, if you passed in the goTo function into the stack, it will show a line that represents where the bot is trying to get to. Or if you pushed an aerial shot, it will draw a line from the bot to the location that the aerial was trying to get to. Same with jump shot, it will draw a line from the bot to where the bot is trying to hit the ball at. And then debug ball path. This requires debug lines, and it debugs the ball path. And there's also this precision right here. A higher precision value actually results in a less precise debug path. Because like, let's say it's 20, which is the max. That means it will skip every 20 points. And now let's say it's 2, it will skip every other point. And that is the debugging GUI. Now, in order to actually debug something in 3D or 2D, or debug a line, do self.dbg2d, and then pass in your value. So it could be anything. And then in order to debug something with 3D, just do dbg 3D. And then in order to draw a line, do self.line, and then pass in your start vector. This can be a list, a tuple, or a vector, which I'll get into in a second. Start, end, and then pass in your color. If you don't pass in the color, it'll default to gray, and that's your debugging tools. Now, as for the vector. Vector is from the agent class, and it is right here. Contains tons of tools, and it is a data class. Something like this, just because you're probably going to be using vectors quite a bit. And all you do in order to define a vector, just vector, and then you pass in the x, y, z. As you can see, there are defaults. So for example, I could say z equals 5, and then it will default x and y to 0. And then you can look through here just to see what kind of things you can do. So this supports most major operations. So you can check the quality, you can add, subtract, multiply, and divide. You can see everything right here. So you can magnitude, normalize, dot product, cross two vectors, flatten a vector, copy a vector, find the 2D angle between 2 points in relation to 0, 0. Find a 3D angle between 2 points in relation to 0, 0. And this will return a value in radians. Rotate a vector or clamp a vector between two different vectors. Find the distance, find the 2D distance, and then just also generic cap on all of the coordinates in a vector. So let's actually build a quick bot with this. So we've already gone for kickoff, and we already know that we're currently not doing anything, so we need to do something. So I'm just going to have a quick shots array, and now I'm just going to find us a jump shot, and this will find a jump shot that will put the ball into the opponent's net. And then if we actually found a shot, just append that shot to the shots list. Now we're just going to find an aerial shot. Then if we could find an aerial shot, append that shot to the shots list. So now if we manage to find a jump shot and an aerial shot, sort the shots list by the shot intercept time. Then push the fastest shot to the stack to be executed. And there we go. Now we have a bot that is the definition of a ball chaser. However, there is one very big problem with this bot, and that is not that it's a ball chaser, but that it will run out of boost very quickly. If self.me, so now this is my car, dot boost is greater than 36, then we're going to find our shot. Otherwise, now we're going to want to find the nearest largest boost pad, and now we're just going to sort all of the active and large boosts by the distance from the car to the boost. And then we just take that fastest boost and push it to the stack. However, we still have a slight problem. If we have over 36 boost, but we can't find a shot, our bot will quite literally just stay there, doing nothing. So if that is the case, I will simply have our bot retreat back to the net. So yeah, guys, I hope this inspired you to go take a look at VirxERLU and try it out, try making a bot in it. So I hope you have a good time, and good luck.